Good morning to all. Today we are going to see a case study on a failure of a helical gearbox, helical gears. So particularly this type of helical gears are used in the gearboxes for the transmission purpose. That too in a high speed machines, maybe in a gearbox as is used in the bus or a heavy vehicles, right? Okay. So these are the things. Before going to the case study, I'll say a glimpse about it. Okay. First one is, this is as I already said, it is used in the bus gearbox. So this gears is used for 3 years. So the material is ASA 8620. It is American Iron Steel Institute. So it is 8620. So these are the evaluation methods. Okay. What are you going to say about this case study?
So as we discussed here, we are going to see about case study of helical gears. So before getting that, we know these helical gears are used in bus gearboxes. So the minimum it will use up to 3 years. The helical gears are used up to 3 years. As I said, it is the material in American Iron Steel Institute. Okay, its number is 8620 steel. Okay. So next, there are many types of failures. As we types of failures means fatigue. Due to fatigue, it will get failure. Impact failures, as well as fracture, it will get fracture, or wear and tear failure it will get. So as well as it will stress rupture, surface contact like fatigue, pitting and sapling will occur in helical gears.
See, the main thing is, sorry to interrupt, the main thing is that I can say it is fatigue failure. It's because in a high speed machine, the major failure that only occurs is fatigue. Okay, we have other types of failures as we discussed in the class. We have other types of failures also, but when we compare for the high speed machines like this gearboxes, fatigue is the major impact, or it will be the major cause of failure. Okay.
So seeing upon these causes, we have poor designing transmission, may be some defects of fatigue and other things. And if a truck is built, it should have a maximum capacity of load. If we are interrupting overload to the bus, we will get fatigue and internal stress to the gearbox, and helical get impact and it can broke. Due to in certain reasons, we have some heat treatment issues on the helical gear, so we have some impact on that.
So appearance of the failure in the helical gears are like, we get the scratches here, in which it causes the failure area. This part is the failure one. Here is the part which has been broken. So it is a failure of the helical gear. The parameters are like the given parameters are number of teeth, and our values are common like 36, and the helical level is 15 degree, and module is 4 mm, and the parameters are goes on. So spectrum, as per the spectrum analysis, as per the source said, the steel is American Iron Steel Institute 8620 carbonate steel. The core hardness is 439 HV, and the surface hardness is 550 HV.
Okay, sorry to interrupt here. Here it is, I already said, you have set a word called heat treatment, right? So this particular gear is heat treated. So at the way it is surface heat treated, means that the area, the teeth where the teeth of the gear is heat treated, or it is hardened. But the core value of the core, what is the inner surface, is not hardened. It means that, so it is reflecting here, the core hardness is only 439, but when compared to surface, the teeth which is going to mesh around will have hardnesses around 550 degrees, 550 HV. HV is that we will see in the class, because hardness test. Okay. So the case depth is 0.63, means it's a surface level and it is a subsurface level. From surface to subsurface, we see it as case depth. So the hardness has been imprinted, or it is boomed inside. So the case depth comes around 0.63. So on that side,
so the microstructure consists of like martensite and the retained austenite. This is the microstructure. So this is the microstructure of helical gear. So visual inspection. So number of teeth, adjacent teeth are failed due in the fatigue. Like after as he said.
So the thing is that if the gear is failed, okay, due to the fatigue, okay. So from here you can see, this is the photograph of the failed section where you can see this is the arrow marks indicates that it's the cracked part. So means crack start part.
Now we are going to see the picture which the destructive fitting was taken, and the spalling is also taken in the gearbox. So this is the defect occurred in the gear. So we are now getting the another image to see the crack initiation point, which was taken in a scanning electron microscope.
Yeah.
So now the crack initiation and propagation was started here. The crack initiated here and the propagation goes on like this.
Okay, so to add a point here, see here you can see some bench marks, like, so this is the fatigue marks, okay.
While coming to the conclusion, the gear was failure due to the fatigue failure, as we concluded using this case study, and this also occurs due to some hardness and case depth found in the gear, and also some misalignment observing can be caused as a failure in this gear.
Moreover, in addition to that, we can see there is a formation of the fatigue, fitting and spalling, which is main cause of the, which is one of the main cause of the failure. So the fatigue is one of the failure which occurs at the high speed gearboxes. Okay, so this is the conclusion of case study. Thank you.